All right, first thing we're going to do is we're going to talk about area of a triangle. Most of you know that area of a triangle is half base height. So in this case, 4 is your base and 7 is your height. So you just plug those in, 1/2 times 4 times 7. And remember, it doesn't matter what order you put these in because they're all multiplying and multiplication is commutative. So if you take 1/2 times 4 times 7 gives us 28. So half of 28 is 14. And if we had a label on each one of these, like if we had 7 meters and 4 meters, then our label would be 14 meters squared for area. In class, we talked about finding the area of figures that we don't know. And one of the things that we talked about was cutting this up into figures that we do know, like triangles. So if we think about cutting this hexagon into 6 triangles, these marks here, remember, mean that these side lengths are congruent. So we would know that each one of these triangles has the same area. So if we can find the area of one triangle, then all we have to do is just multiply it by how many triangles we see, and then that should give us the area of the entire polygon. So the success criteria today, we want to be able to connect area and circumference. Today what we want to be able to do is we want to be able to find the area of regular polygons. All right, so the first thing that we need to do is we need to define what the apothem is. And the apothem, we use the lowercase a to represent the apothem, is a perpendicular segment from the center to one of its sides. So one of the things that we talked about in class is that the apothem cannot go to the corner. So if you see a segment from the center to a corner, this is not the apothem. So what do we need the apothem for? Well, if we think about this, we know that the formula for a triangle is half base times height. So if we put this down here, we're going to do some substitutions here. So 1/2 times base times height. All right, so if we look at this pentagon, regular in terms of polygons just means that all sides are the same length. Okay? So what role does the apothem of the pentagon play for each of these triangles? Well, the apothem is labeled right here. So if we look at this apothem and we go back to this launch that we had, this would be our apothem. So the apothem and the height are pretty much the same thing. So we could take height out of this equation and we could put apothem in. So we have A is equal to 1/2 times something times the apothem. Well, again, if we look at S is the length of each side, okay, so we have S is the length of this side. In this triangle, S would represent our base. So we can take the base out and we can put the side in there, the side length in place of the base. The last thing is this formula right here, as this is written, only represents the area of one triangle. But in order to find the area of the whole polygon, what we need to do is we need to multiply by n, which represents the number of sides. So this leads us to the formula for area of a regular polygon. And in this polygon, or in this formula, we know that S is the side length, N is the number of sides, and A is the length of the apothem. An alternate version that we have is this A equals 1/2 apothem times perimeter. And the way that they get this apothem times perimeter, if you think about what perimeter is just all the lengths of the sides added together. Well, in a regular polygon, all the side lengths are exactly the same. And so we can get the perimeter by taking side length times number of sides. So perimeter in this case is just S times N. So depending on which one you like best, you can either use the A equals 1/2 times S times A times N, or you can use this A equals 1/2 apothem times perimeter. And again, regular polygon just means all sides are congruent. All right. Next thing we want to look at is these side lengths here and then the name of the polygon that goes with it. Most of us know that a triangle has 3 sides and a quadrilateral has 4 sides, but some of these prefixes like penta, hexa, hepta, octa, nona, and deca might be a little bit more unfamiliar. So what I would suggest is writing down the ones that are less familiar to you. I'm not necessarily so concerned with the 11 and the 12, but if you want to, you can write those down for sure. So here in these 2 examples, all we're going to do is figure out what the area of a decagon is with the apothem 12.3 and the side 8 inches. So a decagon, and if you think about decade, a decade has 10 years, so you can think that a decagon has 10 sides. So in this case, N would be equal to 10. So if we write down our formula, A equals 1/2 times S times A times N, we can just start plugging in. 1/2 times 8 times 12.3 times 10. So when we multiply all of this together, get my trusty calculator out. 1/2 is the same thing as 0.5, so you can take 0.5 times 8 times 12.3 times 10, and your answer, your area, is going to be equal to 492, and this time we do have a label, so we're going to label it inches squared. And same for this next example. If you really want to, you can label the figure, so we know that this right here is our apothem because it goes from the center of the figure and it's perpendicular to the side. It does not go to a corner. This is not the apothem. This is not the apothem. The apothem goes to the middle of the opposite side. So the side length is 12 inches. The apothem is 10.4 inches. And we can see that there are 6 number of sides. So again, all we have to do is just take this information. And again, it doesn't matter what order you put them in because multiplication is commutative. So 1/2 times 10.4 times 12 times 6. .5 times 10.4 times 12 times 6 is equal to 374.4. And again, we have a unit, so we're just going to label this inches squared. All right. Next one we'll look at is finding the area when there is no apothem.